Ice piracy is like Pirates of the Caribbean, but you gotta swap those tropical seas for icy, freezing waters. And the captain here isn't Jack Sparrow, but a massive glacier in Antarctica. Meet the Colar East Glacier. Its calm, sparkling surface might look innocent, but don't be mistaken, it is a pirate, and a pretty skilled one too. Instead of gold, it's been stealing ice from its neighbors at record speed, and scientists can't believe what they're seeing. So, what exactly is ice piracy? Arr! This is a strange kind of glacier movement where one glacier starts taking ice from another nearby. Instead of minding its own business and slowly sliding toward the sea, it suddenly changes course and begins pulling ice that used to belong to its neighbor. The pirate glacier speeds up, the victim slows down. The problem is that the balance of ice in the region might get completely thrown off. This isn't brand new information though. Scientists have known about this quirky behavior for quite a while. But they used to think that this process took hundreds, maybe even thousands of years. Now, something really strange is happening in Antarctica. We're seeing, for the first time ever, a glacier pirate in action, and it's moving much faster than anyone expected. It all started when researchers from the University of Leeds began looking at satellite images taken between 2005 and 2022. They wanted to analyze the rates of flow from 8 ice streams in West Antarctica. And yes, glaciers do move. Think of them as huge piles of snow that have turned into solid ice over time. This ice slowly changes shape, shifts, and moves. That's why glaciers are often called rivers of ice, because they flow, for real. Gravity is what makes it happen. The ice slowly slides and deforms under its own weight, thanks to the pull of gravity. And when it comes to glacial movements, they can either advance or retreat. If more snow and ice build up and melt away, break off, or evaporate, a glacier will advance. But if it loses more than it gains, it will retreat. Oh, and glaciers also move at different speeds, depending on things like the slope of the land beneath them. But if that flow starts speeding up, well, that's bad news for coastal communities all over the world, because that means more ice is moving from land into the ocean, which contributes to Antarctic ice loss and, eventually, sea level rise. Now, back to the recent ice research in Antarctica. The team calculated ice velocity using a tracking technique that measures how visible features, like cracks or rifts on the ice surface, shift over time. And they found that 7 of those 8 Antarctic glaciers had sped up. On average, they've doubled their speed since 2005. Given the impacts of how Antarctica's climate is changing, warming up more and more each year, this doesn't really come as a surprise. But here's something strange. One glacier, just one, slowed down. We're talking about the Colar West Glacier. It slowed by about 10% over the study period. But how can a massive chunk of ice just hit the brakes, so to speak? To figure that out, researchers looked at its surroundings, and there it was, the culprit, the Colar East Glacier. Experts think Colar West slowed down because it's flowing toward its pirate neighbor, Captain Whitebeard, Colar East. That one's moving much faster. In fact, it's one of the fastest glaciers in the area. Its speed has been increasing by about 105 feet every year over the study period. Okay, that might sound slow, even for a tortoise. But for a glacier, that's disturbingly fast. Colar East is the Usain Bolt of ice chunks, and that's not even the most impressive part. The strange thing is that it changed its flow direction. Instead of moving straight ahead like it used to, it's now turning towards its neighbor, Colar West, and pulling ice from it. Scientists think this is happening because the ice at the point where the glacier meets the ocean is melting faster than before. That glacier melting makes the ice thinner, and as it thins, it changes the way the ice upstream flows. So now, instead of feeding both glaciers evenly, more of that ice is being funneled onto Colar East. In short, Colar East is speeding up and changing its course. So now it's pulling or stealing ice from its slower neighbor. And just like that, this mysterious glacier in Antarctica became a real ice pirate. Okay, this whole ice piracy thing isn't that weird. It's part of how glaciers normally behave. Slow, dramatic, and occasionally a little mischievous. What really blows scientists' minds is how fast it's happening. They used to think this was a super slow process, something that would take hundreds or even thousands of years. But this one is taking place in just 18 years. And this is a huge satellite discovery in Antarctica. I mean, scientists were only able to spot it thanks to the Copernicus Sentinel-1 mission, a pair of European satellites that use radar to keep an eye on Earth's surface. They can track changes in ice, land, and ocean with incredible precision and coverage, making them perfect for studying how the polar regions are changing. Because here's the thing, keeping an eye on the coldest parts of our planet is becoming essential for our future. And this particular part of Antarctica, where both the Colar West and East glaciers are located, is thinning faster than anywhere else. Its glaciers are retreating at record speed. The grounding line, the point where the glacier stops resting on land and starts floating on the sea, is moving backward. When that happens, the ice sheet slides into the ocean even faster. But scientists say glaciers aren't just melting, they're reshaping themselves in completely new ways. And that's exactly what's happening with the Colar East Glacier. Seeing a pirate glacier in action firsthand has once again changed how scientists look at things. The new data on ice piracy shows something they've never seen before. Glaciers and floating ice shelves are interacting in new and surprising ways. So, more and more, experts need to rethink how these icy giants behave as the world warms up. And that's a big deal, because they play a significant role in how fast sea levels rise this century. In fact, Antarctica's glaciers are one of the biggest reasons our oceans are swelling. The continent is losing about 135 billion tons of ice every year. That's like dumping tens of billions of Olympic-sized pools of water into the ocean annually. If all of its ice melted, sea levels would rise by about 190 feet. That kind of rise would flood much of Florida and huge areas of the Netherlands and Bangladesh, for example. Many small island nations would completely vanish beneath the waves. Now, you might be asking yourself, what's hiding beneath all of Antarctica's ice? Well, it might look flat from above, but underneath that mile-thick layer of ice lies a whole landscape of steep mountains and deep valleys, crossed by winding rivers. Those hidden rivers could play a crucial role in how the ice sheet reacts to all this unusual warmth. Scientists now predict that as Antarctica's ice sheet keeps melting and thinning over the next few decades, those subglacial rivers will grow, overflow, and shift into new paths. This could make some of the biggest glaciers near the coast start to break apart faster, and that would make sea levels rise more quickly. So that's why understanding these changing dynamics and glacier movement, like our icy pirate, is so important. Every new discovery helps scientists figure out what's really driving Antarctica's glaciers and how they are responding to a warming world. The more we learn about these frozen giants, the better we can predict what might happen next, and how changes down in Antarctica could ripple across the entire planet. You're lazing around on the deck of the ship when you see something whitish-gray covering the horizon. Like in a horror movie or your worst nightmare, this weird fog is nearing the vessel. It's infinite. You can't see where it starts or where it ends. Soon it makes the ship look like a grain of sand in a vast desert. That's when the realization hits. It's an iceberg, and your ship is likely going to repeat the Titanic's fate. Now, all this is a very likely scenario, since the world's biggest iceberg, A23A, is on the move again after months of spinning in a huge water vortex. And it's actually the second time in just a couple of years that this massive chunk of ice has broken free. The first time was in 2023, when the berg went wandering around after being stuck on the seafloor for a staggering 37 years. The thing is huge, about 3 times the size of New York City. It also weighs nearly 1 trillion tons. The giant chunk of ice first broke off from Antarctica's Filsner ice shelf back in 1986, but instead of floating away, it got grounded on the seafloor just a few miles from where it started. Because of that, it melted much more slowly than most icebergs. In December 2023, A23A finally broke free and started to drift away from Antarctica. But it didn't get far before getting stuck again, this time near the South Orkney Islands. It got trapped in something called a Taylor column. That's a huge spinning water current that forms when ocean currents swirl around an underwater mountain. At one point, A23A was rotating around 15 degrees counterclockwise every day. Luckily, as of December 2024, the iceberg escaped the Taylor column and is now slowly moving again. Researchers are super curious to see if it'll follow the same path as other giant icebergs that have broken off from Antarctica, or if it'll find its own unique way. Such enormous icebergs, such as A23A, release nutrients into the water as they melt, and it can actually create hot spots of life in parts of the ocean that are usually pretty empty. But there's still a lot we don't understand about how the size, shape, or origin of the iceberg might affect that process. So, to figure it out, scientists have been collecting water samples from the areas A23A is expected to pass through, and they'll keep collecting samples as it drifts along. Hopefully, it'll give us a better idea of how massive icebergs like this one influence the ocean around them. By the way, the glacier our monster of an iceberg was once part of could be very, very old, literally ancient. In Antarctica, the oldest glacier ice might be close to 1 million years old. Over in Greenland, the oldest glacier ice is more than 100,000 years old. And in Alaska, the oldest glacier ice ever recovered, found in a basin between Mount Bona and Mount Churchill, is only about 30,000 years old, a mere child. At the same time, in a typical Alaskan Valley glacier, it only takes about 100 years for newly formed ice to travel through the entire length of the glacier. For something like Bering Glacier, which is Alaska's largest and stretches over 140 miles, the ice can move through the whole thing in less than 400 years, and that's a lot of movement for such a massive glacier. Now let's move on to Iceberg Alley, a stretch of the Atlantic Ocean that runs from the Arctic to Newfoundland. If you want to see as many icebergs as you can, that's the place to be. Tons of icebergs float through this place every year. Most of them come from Greenland. In spring and summer, big chunks of glaciers break off and get carried by north-south currents through Baffin Bay into the Labrador Sea, where they eventually melt. Some icebergs also come from Canada's shoreline, traveling through the Davis Strait and into the Labrador Sea before drifting along Newfoundland's eastern and western coasts. These massive ice chunks are really old too, about 10,000 years. Every year, about 400 to 800 medium and large icebergs pass through Iceberg Alley. How fast they drift depends on their size, shape, currents, waves, and wind, but the average speed is less than a half mile per hour. Now, there are 6 types of icebergs that make their way through Iceberg Alley. Tabular icebergs are flat slabs of ice, much wider than they are tall. Blocky icebergs have steep sides and sharp angles, like cut-off pyramids. Wedged icebergs have one steep side and one sloping side. Dome icebergs have a rounded top. Pinnacle icebergs have one or more steep peaks sticking up. And dry dock icebergs are U-shaped with a hollowed-out section. They all look incredible. Comment below which is your favorite type. Anyway, as these icebergs drift south, the warmer water speeds up their melting, making them pretty unpredictable and sometimes dangerous. Nowadays, satellites help track medium and large icebergs to prevent accidents, but smaller icebergs can still be risky for small boats. One iceberg made headlines in 2018 when it got unusually close to the Newfoundland village of Fairyland. Pictures of the giant iceberg towering over the village's houses went viral. It got stuck in a 330-foot deep water, which turned out to be too shallow for its massive size. And now I'll take you on an unusual journey to the past to witness the birth of something beautiful and equally disastrous. Its very existence led to one of the greatest tragedies in history. Watch, an enormous chunk of ice is breaking off a glacier in southwest Greenland. It's made of snow that fell over 100,000 years ago, when mammoths were still wandering around the planet. The enormous iceberg starts its long journey. It stretches more than 1,700 feet in length and weighs 75 million tons. Despite its size, it's pretty peaceful and stays far away from ships and the busy transport routes near where it was born. But then, it starts floating south, much farther than most icebergs ever get. Usually, icebergs like this melt way before they reach such warm waters. Out of the 15,000 to 30,000 icebergs that drift away from Greenland's glaciers every year, only about 1% make it all the way to the Atlantic. So the fact that this iceberg keeps going and reaches over 5,000 miles south of the Arctic Circle by April makes it truly unique. Even after months of melting, this block of ice is still incredibly massive. It weighs around 1.5 million tons, which is almost twice as much as the Golden Gate Bridge. Above the water, its visible parts tower more than 100 feet high. But like most icebergs, the majority of it, about 90%, is hidden below the surface. The iceberg's story takes a tragic turn on April 14, 1912, when, guess what? Yep, it comes across the ocean liner Titanic. The ship is about 370 miles from Newfoundland in the North Atlantic Ocean when the iceberg seems to appear out of nowhere. The crew doesn't spot it until just minutes before the crash. Why don't they see it sooner? That's a good question. Now, most people imagine icebergs as tall, bright, white chunks of ice, maybe even covered with snow. But in reality, icebergs come in all sorts of colors. Some are striped, patterned, or even have candy-like swirls, and they can also be black. There are two ways an iceberg can turn black. When the ice is extremely pure, with no bubbles or cracks, then it absorbs all the light instead of reflecting it, making it look black. Or a volcanic eruption can cover a glacier in ash. If ice from that glacier breaks off, it can have a dark or black color. Now, scientists still aren't sure why the Titanic's iceberg looked dark, or even if it really did. But one sailor who was on the lookout in the crow's nest said it seemed black. Another described it as gray or dark gray. One theory is this iceberg could have been a blackbird, which forms when the top part melts, causing the iceberg to roll over. If the bottom is smooth enough to absorb light, it looks dark. But even if the iceberg wasn't truly black, nighttime could have made it much harder to spot. Icebergs don't reflect much light, especially if they're jagged or vertical. They end up blending into the dark, shimmering ocean. Without radar, icebergs at night are incredibly hard to see, which is probably why the Titanic's crew didn't notice it in time. Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega tsunami. Back in ancient times, the volcano that crumbled during the mega tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise! It's a volcano! But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients: too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo, and with every peak comes a potential tsunami. Another volcano with similar trust issues is Pythia, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pythia erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pythia experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise. Just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy.
Is the Big Apple getting a little too heavy for its own good? A recent study revealed that New York City is sinking. And get this, it's all because of those towering skyscrapers. Apparently, the whole event is called subsidence, which is when the Earth's surface settles bit by bit, or suddenly sinks. Soft sediments shifting and the weight of the city itself are the culprits behind this sinking sensation. Now, don't get too alarmed. The study found that New York is sinking at a rate of 0.04 to 0.07 inches per year. Sure, that doesn't sound like much, but there are parts of the city that are sinking even faster than that. This sinking situation could cause some trouble for the city, especially since it's already pretty low-lying and home to over 8 million people. So it's important that local authorities come up with some strategies to tackle the growing flood risk and rising sea levels. Although, I'm not sure building giant seawalls is the way to go. We might need to get a little more creative than that. Geologists want to make sure we're all aware that building more high-rises near the coast, rivers, or lakes could contribute to future flood risks. So we really need to think twice before we start constructing skyscrapers left and right. In recent studies, scientists calculated the total mass of all the buildings in New York City, over 1 million of them, and it adds up to a whopping 1.68 trillion pounds. Talk about a heavy load. Now, they didn't include the weight of the roads, sidewalks, bridges, and other paved areas, so you can only imagine how much more weight is added to the city. But hey, even with these limitations, the researchers did a pretty good job of accounting for the complex geology beneath New York, including the sand, silt, clay deposits, and good old bedrock. They found out that certain types of soil, like clay and artificial fill, are more prone to subsidence. On the other hand, bedrock stays pretty firm and keeps those skyscrapers in place. So at least we don't have to worry about the Empire State Building taking a dive anytime soon. Comparing their fancy models with satellite data, the researchers created a map of the city showing where the sinking is happening. And guess what? The increased urbanization and all that groundwater pumping and draining are only making things worse. It's high time we start protecting our resources, don't you think? I wouldn't start packing my bags just yet. New York isn't the only sinking city out there, you know. Jakarta, the capital of Indonesia, is facing some serious sinking action too. In fact, parts of it could be underwater by 2050. That's like a real-life Atlantis situation. Over 30 million people in Jakarta are now deciding if they should relocate the entire city. If there's a city out there we should worry about sinking, that's Venice for sure. But why is it so eager to take a dive, you might ask? Well, let me tell you the complex truth. You see, Venice decided to set up shop on a marshy lagoon with shoddy foundations. As time went by, the ground underneath just couldn't hold it together and started compacting like a squished marshmallow. On top of that, the city's been slurping up groundwater like it's going out of style or something. The cherry on top of this mushy cake is that the sea levels have also been slowly rising. And guess what? Those sneaky plate tectonics are having a laugh by shoving the Adriatic plate under the Apennine Mountains, giving Venice an extra push downward. Someone had the bright idea to stop pumping groundwater, thinking they could stop the sinking shenanigans. But hold your gondolas. A new study revealed that the sinking hasn't completely stopped, just slowed down a bit. It turns out the whole area is tilting ever so slightly to the east, with Venice perched on the slightly higher end. You must be wondering how much Venice sinks in a year, right? Brace yourself for this shocking revelation. It's sinking at a rate of about 0.04 to 0.07 inches a year, similar to New York. At this pace, in the next 20 years, it could sink a whopping 3 inches below sea level. To avoid turning into a Venetian fishbowl, locals are frantically building special barriers to keep the water from crashing into the lagoon. But don't hold your breath, because this project has had more delays than you'd expect. Oh, and have you noticed that charming old-style vibe in Venice? It's not just because they're fans of the vintage look. Those salty waters have been wreaking havoc on the buildings, thanks to the water levels constantly breaching the original damp-proofing. Now the water's cozying up to the masonry, and the ground floors of many apartments are no longer safe enough to live in. Now, when will Venice take a dive into the abyss? It's hard to say for sure. Subsidence and rising sea levels are as slow and unpredictable as a turtle in a marathon. But experts have playfully warned that if things continue as they are, Venice could be doing the backstroke beneath the waves by 2100. Fear not, though. They're doing their best to protect this floating gem of history and culture from becoming a Hollywood disaster flick. So don't cancel that Venice day trip just yet. New Orleans has a peculiar watery situation going on too. You see, this lively place was initially built just a smidge above sea level, and now it's gradually sinking. Back in the day, when an area of the city called the French Quarter was just popping up, folks had to make do with what they had. They scored the best land they could find, but it was only about 10 feet above sea level. And let's not forget, the rest of the city is as flat as a pancake, with the areas around the French Quarter being just a hair lower. Now, even though they knew they were up against some soggy odds, the resourceful New Orleans residents did their best to elevate their houses above the flood-prone land they chose as their home. There's more. The ground beneath New Orleans is as wobbly as a plate of Jell-O. Architects had to keep things short and sweet because they feared the soil couldn't handle the weight of taller structures. They played it safe, sticking to 2 or 2.5 stories. Here's where it gets interesting. The city installed a fancy drainage system in the 1900s, thinking it would solve their water woes. And while it did help with the marshes and all, it inadvertently sucked the life out of the soil. Yep, the ground was left high and dry, without enough sediment and water to keep it steady. As a result, those former marshes sank as if they were in a quicksand competition. By the 1930s, things got even more topsy-turvy. 1/3 of the city was below sea level, and by the time Hurricane Katrina made its grand entrance, that number skyrocketed to around 50%. Oh, and here's the icing on the cake. Sea levels decided to join the party, rising faster than a helium balloon. So now, not only is New Orleans sinking, but the surrounding area is also at various degrees below sea level. So, what can we do about all these sinking cities? Well, for instance, we could manage our water consumption a bit better. We can't just keep sucking groundwater out of the earth like there's no tomorrow. We've got to find new ways to quench our urban centers' thirst. Think about it. We could purify surface waters, or even turn salty seawater into a sweet solution. Of course, we'll need a boatload of energy to make it all work. Speaking of great urban water management, let me tell you about a town in Denmark called Nye. These guys have got it all figured out. They collect rainwater and use it to supply their toilets and washing machines. Talk about resourcefulness. Now that's what I call a splash of genius.
A beam of electric light pierces the darkness over the calm waters of the Atlantic Ocean. The Titanic is quietly making its way through the waves, its passengers asleep, when suddenly a monstrous white shape is caught in the light beam. The fateful Iceberg is about to rend the side of the legendary ship. April 14, 1912, only 2 days before someone will take a photo of a giant iceberg with a pretty unusual elliptical shape. It turns out that this iceberg most likely formed out of snow that fell 100,000 years ago. Researchers used computer modeling to figure out its origin. They used data from 1912 and added some new information about winds and ocean currents. They concluded that the iceberg was probably a part of a small cluster of glaciers in southwest Greenland. These days, it's possible to calculate the routes of such icebergs in any given year in the past. So the infamous chunk of ice was on its way from Greenland to an area further south from Cornwall. If the ship had passed through that region only 2 days later, the iceberg would have moved far away from the point where they met. At first, the weight of the most well-known iceberg in the world was 75 million tons. With time, it started to slowly melt away. And when it sank the Titanic, its weight was only 1.5 million tons. By the time of the collision, it had probably been melting for months, but it was still a true monster. When the Titanic sank, the iceberg was 400 feet long, and more than 100 feet of its surface was above the water. Some people believe it was a supermoon that caused the Titanic to sink. That night, there was a rare lunar event. It hadn't happened for 1,400 years. In normal conditions, the iceberg wouldn't have traveled so far south without melting and losing the largest part of its mass. But the supermoon could have been the reason for an unusually high tide that pulled the iceberg away from the glacier way faster than usual. There's a specific type of bacteria that slowly consumes the remains of the Titanic. Salt corrosion, ocean currents, freezing temperatures, plus this rust-eating microorganism might consume the entire wreckage. American actress Dorothy Gibson was aboard the Titanic. She survived, and when she arrived in New York, she started filming a movie called Saved from the Titanic almost right away. The movie was released only a month after the Titanic sank, and in the movie, she even wore the same shoes and clothes she had during the actual disaster. The movie was a big success at that time, but the only known copy was destroyed in a fire. 14 years before the Titanic sank, a novella called Futility had been published, and it seemed to have predicted the whole event. The plot centered around a fictional ship called the Titan that sank during its voyage. The Titan was almost the same size as Titanic, and they both went to the bottom in April. The reason was hitting an iceberg, too. Both the real and fictional ships were described as unsinkable, and both of them had the legally required number of lifeboats, which, as it turned out later, were nowhere near enough. We've seen it in the movie, but there were some real-life love stories happening on the Titanic, too. 13 couples even took a trip on the Titanic as part of their honeymoon. One of the couples owned Macy's department store in New York. Once it became clear the Titanic was rapidly sinking, the woman refused to go into a lifeboat without her husband. But he didn't want to join her while there were still women and children who he thought had to go first. Then his wife gave her coat to her maid. She insisted that the maid should get into the lifeboat, and she wanted her to be warm. As for the woman herself, she decided to stay with her husband till the end. Some people believe Titanic sank because of a mummy, not an iceberg. It all started around 1000 BCE with a mysterious woman who lived in Egypt, in the City of Thieves. People knew little about her, but they called her a priestess. Her mummy was put in a wooden sarcophagus and covered with a large lid with the image of her face and some mystical inscriptions. This place had been hidden until the first half of the 19th century, when a group of locals accidentally came across it. They disturbed her peace. No one knows how, but the mummy disappeared that day without a trace. A couple of decades later, a group of rich friends from England traveled to Egypt and found the empty mummy casket with the image of the priestess, whose dark eyes seemed to be looking into the void. They decided to buy it, but the buyer disappeared the same night before he even got the case. All members of the group had some accidents. The casket changed its location a couple of times until it, as some believe, ended up on the Titanic. It took more than 70 years for a robot submarine to find the ruins of this legendary ship. The wreck lies nearly 13,000 feet under the surface of the Atlantic Ocean, split into two halves. Why did the liner break apart? No one knows exactly. Some think it happened because of the water that got inside when the ship collided with the iceberg. The pressure was so powerful it separated two parts of the vessel, starting with the ship's bottom structure. Others say it was because of the hull rivets. They had a high concentration of slag or smelting residue, and that's something that can cause the metal to split apart. The ship generally had many flaws, starting with the design. The watertight bulkheads weren't completely sealed on top. This allowed the water to flow between the compartments and, in the end, sink the vessel. The iron of the ship's rivets and steel of the hull ended up ruined because of high sulfur content, cold temperatures, and high speeds. The steel shattered and the rivets popped out quite easily. Because of this, Titanic sank 24 times faster than it would have otherwise. If the ship had hit the iceberg head-on instead of ramming it with its side, it would have probably stayed afloat. How come the crew members didn't have binoculars? It would have surely helped them spot the iceberg on time and maybe even avoid the disaster. But the binoculars on the Titanic were locked in a storage cabinet. Only one crew member had the key, and he had been transferred off the ship right before it set sail. He later said he hadn't remembered to hand over the key. But even without the binoculars, the ship might have had some time to change course and avoid the collision if the crew had gotten some warning. But that's the thing, someone did warn them. About an hour before the incident, a ship that was relatively close to Titanic, the SS Californian, sent a message to inform them it had stopped because of dense ice field. But the warning never got to the Titanic's captain. Some experts say it was because the radio operator didn't think it was that urgent. And later, the SS Californian said they didn't get a call for help from the Titanic because their radio operator was off duty. Some say the crew on the Titanic couldn't spot the iceberg on time because of an optical illusion. Atmospheric conditions that night probably caused superrefraction, which could have camouflaged the berg. After all, no one actually saw the iceberg until it was too close to the ship to somehow avoid the crash. Not even a whole minute passed between the moment they saw the iceberg and the collision. It was only 37 seconds, and it took Titanic 2 hours and 40 minutes to disappear below the ocean's waves. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Draupner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of 3 large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas fault line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas fault line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the US around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something it can cause more damage than the big one. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate, and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put two and two together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's Oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where 2 pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's Oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the 2 plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only two confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave, but the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake, with an epicenter southwest of Cape St. Vincent, triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers. Because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe.
On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia subduction zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia subduction zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia subduction zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest. And water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top 70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia subduction zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a megathrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and a million times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia subduction zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake. A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse. All food chains would be broken. And only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earth shake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States like the Klamath and San Joaquin all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used 2 kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together. So, there's a mysterious doorway in the middle of Antarctica. Some people think it's Bigfoot's vacation home, or a shuttlecraft from Star Trek, or maybe a door to Agartha, a mythical kingdom some people believe is located in the center of the Earth. Well, the scientists debunked all these poetic theories and explained that what looks like a mysterious doorway is located in an area of fast sea ice. It's offshore of the coast and is full of little islands with shallow water around them. When ice flows around hard rocks hidden underneath, it can create patterns that look odd but are totally normal. In this spot, the ice is thin, so the rocks underneath have a big effect on how the ice moves. The cold winds in Antarctica also shape the ice and snow and make it look like they're lines and shapes. So, the mysterious doorway is just a rocky ridge poking out because the ice has melted a little. The top of the doorway is the tip of the rock, and the sides are snowy trails left by strong winds blowing in the same direction. It's essentially an iceberg that got stranded and is melting in one place. One YouTuber found another out-of-place mysterious object more than 150 miles off the shore of Antarctica, a 400-foot-long ice ship. The internet went wild with theories like that this ship must have ended up there right from the Bermuda Triangle. But there was no scientific proof that it was a ship and not just a large chunk of ice. And once some other internet users revisited the place, they noticed the ice melted in the summer and the hypothetical ship was gone. Another mysterious Google Maps find in Antarctica was a pyramid. And before you make up an exciting theory about how the ancient Egyptians built a secret base here, I have to tell you it turned out to be just a mountain. It's part of the tallest mountain range in Antarctica that stretches for almost 250 miles. It's not the first pyramid on this continent, as explorers from the British Antarctic expedition found another unusually shaped mountain and nicknamed it the Pyramid. But this one didn't even have a pyramid shape. Here's one Antarctic find that definitely won't disappoint you: a giant ice shelf that reminded scientists of the Grand Canyon. A special submarine robot named RAN covered over 600 miles under the thick ice and brought back some amazing footage of icy mountains, valleys, flat plateaus, and swirly patterns made entirely of ice. One of the strangest things RAN found was giant bowl-shaped holes or scoops in the ice. Sadly, scientists lost track of the robot. They think that curious Wendell seals may have accidentally bumped into RAN and caused it to get stuck. To save energy, RAN probably shut itself down, and the scientists couldn't find it again. But the team is hoping to build a new robot and continue exploring this icy canyon to see how the patterns under the ice might change over the years. Another huge Antarctic canyon was found thanks to bad weather. A team of sound experts had to pause their work at the Casey Research Station in a storm. Instead of waiting around, they decided to use the unexpected free time to map the seafloor near Adams Glacier. And that's how they found a canyon that is almost 7,000 feet deep, almost 30,000 feet wide, and stretches over 28 miles away from the glacier. During the mapping, they discovered just part of the canyon before they had to go back to the research station. But when bad weather came in again, the ship went back and mapped more of the canyon. They were working in waves up to 13 feet high and super powerful winds, but they managed to get about 15 hours of data to complete their map. On the way back to Australia, they stopped one last time, and now they've got a full picture of the canyon. Studying it is helping scientists learn more about the history of glaciers and the interaction between the Antarctic ice sheet and the ocean. Now, there's a frozen lake in Antarctica called Lake Enigma. For a long time, people thought the lake was completely frozen solid. But during one expedition, researchers found that under the thick ice, there was a layer of liquid water about 40 feet deep. To learn more, they drilled through the ice and sent down a camera to explore what was hiding in the lake's depths. The lake's water, which they think comes from the nearby Amorphous Glacier through a secret underground pathway, was filled with strange microbial life. These tiny microbes lived in mats that covered the lake bed. Some of the mats were thin and spiky, and others looked like crumpled carpets, or even small tree-like shapes that grew up to 16 inches. Many of the microbes could make their own food through photosynthesis, just like plants do, and it gave the lake a high amount of oxygen. One of the coolest discoveries was a type of microbe which usually lives in low-oxygen places. Lake Enigma might be similar to environments on icy moons like Europa or Enceladus, so it could mean that these moons also have hidden water under their ice and possibly microbial life too. One more mind-boggling discovery from Antarctica is tiny pieces of amber in mudstone, found here for the very first time. It took scientists years of studying incredibly well-preserved fossilized roots, pollen, and spores that they found back in 2017. Amber proves that resin-producing trees once grew in Antarctica, part of a lush rainforest that existed near the South Pole during the mid-Cretaceous period. Back then, disclaimer, I wasn't around then, the trees would have had to survive through months of darkness during the long Antarctic winters. Scientists believe they adapted by going dormant for a long time. The amber pieces the scientists found are tiny, but they are beautiful shades of yellow and orange with bumpy surfaces that show how the resin flowed out of the trees. This resin likely leaked out to protect the trees from insects. It was preserved because water quickly covered it and kept it safe from sunlight and air. A scientist was browsing through satellite images for brown trails of penguin waste and found 4 new colonies of emperor penguins at the base of the globe. These new colonies likely have been around for years, though 3 of them are rather small, with fewer than 1,000 breeding penguins each. One of the new colonies was found close to a place called the Lazarev Ice Shelf, where there used to be a larger penguin colony. They thought this colony went extinct in 2019, but it seems the penguins have just moved a bit because of changing sea ice conditions. So studying them can help us learn more about how emperor penguins adapt to changes in the environment. Now, there used to be a giant river system in Antarctica 40 million years ago. Researchers found proof of it after studying soft sediments and hard rocks from the frozen seabed. They looked at tiny bits of radioactive elements, like uranium and lead, and learned that the deeper dirt came from the time of dinosaurs. The dirt closer to the surface was younger and had an interesting pattern, like the kind you see in river deltas today, such as in the Mississippi River or Rio Grande. Scientists found tiny signs of life in the sand. The river that once flowed here started in the Trans-Antarctic Mountains and traveled 930 miles before it reached the sea. Researchers kept studying newer layers of dirt from about 20 million years ago. They hope this will help them predict what the Earth's weather patterns might be like in the future.
Leave it to people wandering on Google Earth to stumble upon the world's newest and weirdest places ever. Like this mysterious pyramid discovered in Antarctica. Soon enough, the internet blew up with all sorts of theories regarding this unusual shape. Could it be a sign from a different life form? Is this pyramid indeed natural, or is it man-made? For starters, it's not the first time we've discovered a pyramid in the Antarctic. The first one was observed by the British Antarctic expedition in the 1910s and kept secret for a long time. Its discovery being kept hidden only added to the mystery. A second such structure was discovered in 2016, which further increased the interest in the matter. The mystery was soon enough deciphered by scientists. These formations are just mountains. They're located near the Ellsworth Mountains, a range over 250 miles long, so they're just mountain peaks that have broken through the ice sheet. As for their particular shape, it's just a coincidence. Pyramids are found throughout nature. The Matterhorn in the Alps and Mount Ballenstinder in Iceland, for example, are quite similar in terms of shape. As for the official name of these peaks, they're called nunataks, or peaks of rock peeking through a glacier or an ice sheet. Antarctica has way more incredible features, like the fact that it's home of 60 to 90% of the world's fresh water. That's because its ice sheet is the biggest on our planet, stretching across 5.4 million square miles. I'll spare you the calculations, but that leaves only 1% of the continent ice-free. Antarctica's ice reaches 2.7 miles thick at its deepest point, meaning half the height of Mount Everest. Should it ever melt completely, our sea levels would rise to roughly 200 feet. It wasn't always this cold, though. At some point in our planet's history, Antarctica had some average temperatures as the city of Melbourne has today. It took a lot of research, but scientists figured out that Antarctica's temperatures could have reached up to 62.6 degrees Fahrenheit. Sure, that was 40 to 50 million years ago, but if you think about it, it was at the same time when dinosaurs roamed our Earth. Time is also different on this icy continent. All the lines of longitude that help us calculate different time zones merge into a single point at the South Pole. Here, there are 6 months of daylight in the summer, followed by 6 months of complete darkness during the colder season. So, scientists working here stay, on average, in the same time zone they've come from. The Bloodfalls aren't a chapter of a thriller movie. They are merely a series of waterfalls located in one of the driest regions of Antarctica. They emerge from an underground lake filled with a special type of bacteria. These little organisms use sulfates as fuel instead of sugars, which makes them very intriguing for scientists. The water contained in this lake is so full of iron that it basically just rusts when it meets air. So, the reddish color of the waterfall also gives it its trademark name. The megalodon was the largest predator ever known in our planet's history. In terms of its location, the megalodon lived practically in all waters on our globe, except near the poles. The reason why there are no megalodon teeth found in Antarctica is probably because the gigantic creature was adapted to only warm tropical and subtropical waters. If you plan to visit Antarctica by boat someday, just know you might not get there on a non-metallic boat. The hull of your transportation device must be made of either steel or aluminum to withstand the harsh weather conditions here. Antarctica isn't home to a lot of bugs. In fact, there is only one true species of insect that calls this place home. It's a wingless midge called Belgica antarctica. This fly is so tiny that it only reaches 0.08 to 0.23 inches long, but it's still the Antarctic's largest terrestrial animal. A lot of Antarctic fish also come with an antifreeze substance in their blood. They don't necessarily need it for protection against the cold temperature, but mostly against touching ice. These antifreezes are made up of large glycoprotein molecules. They surround any small ice crystals that may form, making sure they don't spread through the animal's tissues, which could cause a lot of damage. They also create a sort of small pillow blocking the sharp ice crystals, so they're less likely to cause any pain. It also doesn't rain a lot here on this icy continent, but one amazing meteorological quirk of Antarctica is that it's full of diamond dust. This dust is basically small ice crystals that pop out of humid air close to the Earth's surface. Think of it like an icy fog. As they flow through the air and get touched by sunlight, they begin to sparkle, making visitors here feel like they're surrounded by diamonds. It's probably the last place you'd want to go into labor, but in 1978, the first person was born here ever. Emil Marco Palma was its name, and ever since, 10 other people have been born here in Antarctica. There's a lake on this icy continent that is so full of salt, it makes it impossible for it to freeze over, even if temperatures can go as low as 5 degrees Fahrenheit. That's because pure water freezes at 32 degrees Fahrenheit. Water that has salt in it, or any other substance for that matter, will freeze, but at a way lower temperature. That lower temperature is adjustable depending on the substance itself and the amount that has been placed into the water. Antarctica was the last official continent to be discovered. It remained completely unseen until the 1820s. But it took another 20 years to confirm it was actually a continent and not just a group of icy islands. Just because it's really cold here doesn't mean you can't go on a date here. One December night, an American scientist that was posted in Antarctica logged into a dating app simply out of curiosity. He was certain no other profiles would show up, but to his surprise, he found someone soon enough. Another researcher who was stationed just 45 minutes away, by helicopter of course. They eventually got together and went on the first date in Antarctica ever recorded. Apart from ice, this continent has something else way more abundantly than any other piece of land on Earth: meteorites. If we look at the research done by scientists, meteorites have equal chances of reaching any place on our planet. However, once they go through our atmosphere, the situation is a bit more complex. That's because different climates on our planet, like the humid ones found near the jungle, have a lot of moisture and oxygen, which will corrode most meteorites. The climate in Antarctica is really dry, so the possibility of meteorites corroding is little to none. More so, it's way easier to spot these rocks on the icy white surface of this area than in any other place on Earth. If you're not scared of the cold, you'll surely freak out when you hear about the winds here. That's because Antarctica is for the most part the windiest place on Earth. Wind speeds have been reported here to reach even 200 miles per hour.
We've all dreamed of visiting the Arctic and witnessing the natural wonders of polar bears frolicking on ice floes or the aurora borealis dancing across the sky. Well, sorry to break it to you, but you won't find any tourists flocking to Antarctica anytime soon. Why, you may ask? Let's dive into it. First off, where is Antarctica? It's located in the southern hemisphere, specifically at the South Pole. The Southern Ocean surrounds it, and most of the continent is covered by ice, making it one of the most remote and frigid places on Earth. Now, have you ever met someone who's visited Antarctica? Probably not. It's one of the least visited places on the planet, and only a handful of lucky explorers have seen its interior, which is mostly made up of glaciers and ice fields. But trust me when I say the wildlife and scenery are out of this world. Why shouldn't you travel to Antarctica? Well, for starters, the environment is incredibly fragile and can be easily damaged. Plus, there are no native human populations on the continent, so your travels would essentially be like visiting an uninhabited island. And let's not forget that it's also one of the most expensive destinations to travel to. Despite all that, Antarctica is not exactly guarded like a fortress, but there is an international agreement called the Antarctic Treaty. This treaty was negotiated to prevent any unwanted activity on the continent and bans some forms of testing done there by member states. But the primary reason we can't just waltz into Antarctica is that it has a delicate ecosystem that needs protection. The treaty states that Antarctica should be used for peaceful purposes only and should be free from any human activity that could harm the environment. Scientists are still learning about the continent's unique ecosystem, and our activity and machines could disrupt the delicate balance that exists there. If you're still itching to go to Antarctica, getting permission isn't exactly a walk in the park. U.S. citizens, for example, need to complete a special form and send it to the Office of Ocean and Polar Affairs. And once you're there, you'll need to follow some strict guidelines to protect the environment, like not disturbing any wildlife or taking souvenirs like rocks, plants, or animals. Now, technically, can you live in Antarctica? While there are no laws banning people from living there permanently, it's a very inhospitable environment and unsuitable for human habitation. Temperatures can reach -76 degrees Fahrenheit and below, making it nearly impossible for anyone to survive without the proper equipment and experience. Plus, the nearest piece of land is over 1,000 miles away, making any inhabitants completely cut off from the rest of the world. Who knows? Maybe one day we'll get the chance to visit this unique and fascinating continent. But until then, let's admire it from afar. Let's now talk a bit about the discovery of Antarctica. Unlike other places that were already inhabited, Antarctica never had a native human population. Ancient Greek philosophers had an idea about the continent and called it Antarctos, meaning opposite the bear. The bears it refers to are not the polar ones though, but rather the Great and Little Bear constellations, which are only observable in the northern hemisphere. As a result, the term signifies the opposite of the land of the bear. Whaling and sealing voyages in the late 1700s and early 1800s would venture further south when rounding Cape Horn at the tip of South America. It was known that going further south often meant stronger winds, but also the risk of hitting floating ice of all sizes and of winds and seas that could prove dangerous to the ship and crew. Captain James Cook was the first to cross the Antarctic Circle on January 17, 1773, in the Ross Sea region. He reached a point further north a year later, and though he didn't sight land, he came to within 50 miles and saw deposits of rock held in icebergs, indicating that a more southerly land existed. The first sighting of Antarctica is widely acknowledged to have taken place in January of 1820, during the voyage of two ships under the command of Captain Fabian Gottlieb von Bellingshausen, as part of a 2-year exploratory expedition around the world to discover new lands. The captain's ships were the first to have crossed the Antarctic Circle since Cook. The first undisputed landing on Antarctica didn't happen until much later, on January 24, 1895, at Cape Adare during the whaling voyage of the ship Antarctic, led by Henrik Bull. A small boat with 6 or possibly 7 men on board rowed ashore during calm conditions. You might not believe it, but Antarctica is actually a desert. With all that ice, you'd think it'd be like a winter wonderland with snowball fights and hot cocoa all day long. When we think of deserts, we picture camels and cacti and people struggling to find water. But in Antarctica, it's a whole different story. The struggle isn't to find water, it's to find anything that's not covered in ice. And the average rainfall has been just over 0.4 inches in the past 30 years. That's like a few drops of rain compared to what we're used to. So technically, it's not the dunes or sizzling heat that makes a desert, well, a desert. It's the lack of precipitation. But don't worry, if you ever find yourself lost in Antarctica, you won't have to worry about getting thirsty. Just make sure you bring a jacket and some mittens, because it's cold enough to make you into a popsicle. Not only is Antarctica one of the driest places on Earth, but it's also the coldest, the windiest, and the highest. Talk about overachieving. The penguins and scientists down in Antarctica have at times found themselves in a bit of a pickle when it comes to time. You see, unlike the rest of us on this big blue planet, there is no Antarctica time zone. All the lines of longitude meet at a single point at the South Pole, making it a bit of a head-scratcher when trying to figure out what time it is. Now, you might be thinking, but how do the scientists and researchers keep track of time down there? Good question. They typically stick to the time zone of the country they departed from. However, with stations from all over the world on the Antarctic Peninsula, things can get a little wacky. Imagine trying to coordinate with your neighboring countries without accidentally waking them up in the middle of the night. You might think that not much could survive in a place where the temperature is extremely cold, the sun barely shows up, and the wind could blow you away faster than a tumbleweed. Well, as in many places on Earth, life found a way in Antarctica too. Believe it or not, this frozen continent is buzzing with activity. It's home to billions of krill, which in turn attract lots of seals and more penguins than you can shake a fish at. But don't let their cute and cuddly appearance fool you. Penguins are the ultimate swimmers, with streamlined bodies that would make Olympic medal winners jealous. They come ashore to breed and chill, but their real talent is stealing pebbles from each other and forming mathematically precise huddles to stay warm. Antarctica is also home to the largest species of penguin on Earth. It's called the emperor penguin. Sure, these creatures are flightless birds, but that doesn't mean they can't jump. In fact, some of them can leap up to 120 inches. And let's not forget about the seals. With their furry bodies and special songs, these marine mammals are protected by the Antarctic Treaty, and they're thriving in the cool waters of the Southern Ocean too. But the real stars of the show are the whales. During the Antarctic summer, these huge creatures show up in droves to chow down on the abundant krill. It's indeed like a whale buffet down there.
In 2011, scientists from Chile found a weird-looking fossil in Antarctica that looked like a squashed football. Almost 10 years later, the rock just sat on a shelf in Chile's National Museum of Natural History with no specific label. It went by The Thing in the museum because it looked like something from a science fiction movie. When the scientists finally got their hands on the strange fossil, it turned out it was actually a giant softshell egg from around 66 million years ago. This one is more than 11 inches long and 7 inches wide. A regular chicken egg is just 2.5 inches long, and an ostrich egg is almost 6 inches long for comparison. So, The Thing won the title of the biggest softshell egg ever found and the second largest egg of any animal we know of. The only bigger egg that was ever found was that of the extinct Madagascan elephant bird, which is also 1.5 times as tall as Michael Jordan. The bird, not the egg. The Antarctic egg is also special because it's the first fossil ever found in this part of the world. So, whoever left it there must have been one big creature, probably a giant sea turtle that lived long ago, like a mosasaur. This is surprising because most scientists thought these creatures didn't even lay eggs. So this discovery could change what we know about them. The egg is also unique because it has a thin eggshell and no pores, which is totally different from most dinosaur eggs. It actually looks more like the eggs of lizards and snakes, but it came from a giant creature related to these animals. No known dinosaurs or flying reptiles from that time and place were big enough to lay such a huge egg, so it must have been a mosasaur after all. But we can't be 100% sure. Scientists did a lot of work and studied 259 types of living reptiles, like lizards and snakes, and their eggs. From this, they figured out that the mommy who laid the egg was probably at least 23 feet long, not counting her tail. During the late Cretaceous period, this part of Antarctica might have been like a nursery. Paleontologists have found bones of tiny mosasaurs and plesiosaurs in the same area, along with bones from the grown-up ones. Archaeologists in Norway made another cool but literally discovery and found dozens of arrows that had been hidden in ice for 6,000 years. They were melting out of a large ice patch in the high mountains, covering an area of about 45 football fields. In 2014 and 2016, when the summers were extra warm, scientists went to an ice patch called Langfoni to look around. They also found lots of reindeer bones and antlers there. Some of the arrows were whole and some in pieces, along with 5 arrowheads around the melting ice patch. This is more arrows than have been found at any other frozen site in the world. Some of the 68 found arrows date back to the Neolithic period, and the newest ones are from the 14th century of the Common Era. Ice is like the perfect time machine that can preserve whatever ends up there in an almost perfect condition. Langfoni became famous as one of the first ice patch sites after a local hiker found a 3,300-year-old leather shoe right next to its edge. Scientists are studying places like this to understand how people use these sites and how the ice patches from Norway to North America changed over time. Now, once upon a time, around 32,000 years ago, to be exact, a squirrel buried some seeds near a river in Siberia. Am I the only one getting the Ice Age vibes? Anyway, these seeds belong to a plant with cute white flowers. Thousands of years later, a group of scientists found these seeds buried deep in the frozen ground, about as far down as a 12-story building is tall. The seeds were surrounded by ice and bones of animals like mammoths, bison, and woolly rhinoceroses. The mature seeds had been damaged, maybe by some squirrel, but some of the younger seeds still had good plant parts inside them. The scientists carefully took those out and put them in small containers to help them grow. And here comes the coolest part. They were able to grow the plants. Their flowers were shaped a little differently from the flowers of the same plant that grows today. After a year, the Ice Age plant even made new seeds. Based on this, the scientists suggested that permafrost could be a depository for an ancient gene pool, and we could find extinct species there and bring them back to life. Scientists on an icebreaker in Antarctica were looking for whales but found something way more unusual. The camera behind the ship, which is as heavy as a car, detected 16 million icefish nests on the floor of the Weddell Sea. The nests were located about every 10 inches in all directions and covered an area of 93 square miles, which is slightly bigger than the whole of Washington, D.C. The colony even had a distinct border, which was a line in the sand. The scientists were in the area because they were studying a special spot in the ocean where the water was a little warmer than the water around it. In this warmer water, they found tiny animals called zooplankton near the top. When the young icefish hatch, they swim up to this area to eat the zooplankton before going back down to the seafloor to grow up and have their own offspring. Since there was so much food, it made sense to see icefish in this warm water. But they didn't expect to find such a huge number of icefish nests, much more than anyone had ever seen before. New Zealand's Antarctic Heritage Fund found some old photo negatives in a hut in Antarctica. They turned out to be unique images from the Ross Sea Party. It was a famous failed expedition led by Ernest Shackleton. He wanted to become the first person to cross Antarctica by land, from the Weddell Sea to the Ross Sea, passing through the South Pole. But things went wrong when their ship, the Aurora, was blown out to sea. They had to use the hut from another explorer, Captain Robert Falcon Scott. His goal was to be the first person to reach the North Pole, but sadly, he didn't succeed either. The negatives were made of cellulose nitrate and were found stuck together in the small box. The Trust took the negatives back to New Zealand, where they carefully separated them and discovered 22 hidden images. Many of the photos were damaged, but the trust could still recognize some familiar places around McMurdo Sound, a well-known area in Antarctica. No one knows for sure who took the pictures. In December 2021, some scientists noticed a strange mark on the Larsen ice shelf, a giant sheet of ice off the eastern coast of Antarctica. They thought it might be a river flowing under the ice, so they drilled down over 1,600 feet to check it out. They expected to find water, but they didn't expect to see that the water was full of fast-moving creatures called amphipods. The scientists also found that the water in the underground river had unusual layers of currents moving in different directions, which they still don't fully understand. Another surprising thing happened during their research. On December 20th of the same year, a volcano erupted far away in Tonga, and the pressure waves from the eruption were detected all the way down in the ice river in Antarctica. It shows how everything on our planet is connected, even in the most distant places. Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well, off the western coast of Australia and near New Zealand. They recorded similar but higher pitch signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a hey of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduct, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. how about we end this video with a mystery that still baffles scientists? Meet upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it. Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cascadia, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Tsunamis eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity. and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sundhnúkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.
It was the beginning of the 20th century, and two rivals, Robert Scott and Roald Amundsen, set on their expeditions to become the first people in history to reach the South Pole. The race wasn't easy, and it ended tragically for Scott. Amundsen has won and set his tent on the pole before his rivals. A member of Scott's expedition known as Terra Nova, British geologist Thomas Griffith Taylor, not only survived the harsh conditions but also made an unexpected discovery. He found a waterfall of what appeared to be blood at the rocky base of the glacier, which now has his name, in 1911. It took scientists more than a century to figure out what is behind the eerie coloring. A team of American scientists journeyed to Taylor Glacier with powerful electron microscopes to analyze its contents. Previous studies had scratched the surface of the Crimson Enigma, but no one had previously done a full-scale analysis of its mineralogical makeup. These researchers unleashed a whole arsenal of analytical equipment and spotted little iron-rich nanospheres. These teeny-tiny particles, 1/100th the size of human red blood cells, originate from ancient microbes. They flourish abundantly in the meltwaters of Taylor Glacier. These nanospheres are jam-packed with iron, silicon, calcium, aluminum, and sodium, forming a unique composition that paints the subglacial water a vivid shade of red. These nanospheres don't have the usual crystalline structure found in minerals, which is why previous detection methods failed to spot them. Taylor Glacier's icy depths harbor an ancient microbial community that has thrived in isolation for thousands or possibly even millions of years. This discovery could help us in the search for life outside of Earth. Dr. Ken Levy, a research scientist at Johns Hopkins University, has some impressive expertise in planetary materials and the analysis of Martian samples. He decided to find out what would happen if a Mars rover landed in Antarctica. Could it figure out what makes Bloodfalls so mesmerizingly red? So, researchers treated Bloodfalls as a simulated Martian landing site. They used techniques inspired by the rovers exploring the red planet. The samples they collected were sent to Johns Hopkins processing facilities. There, Livy unleashed the power of transmission electron microscopy and revealed the enigmatic nanospheres. He made the conclusion that our current methods of analyzing other planets' surfaces with rovers fall short. They can't unravel the true nature of environmental materials, especially on chilly planets like Mars. These materials might be super tiny and non-crystalline, throwing off our detection methods. To truly grasp the essence of rocky planets, we'll need transmission electron microscopes. Strapping one onto a Mars rover isn't feasible yet, but it could mean a start of a new era in space exploration. Have you ever seen a waterfall on fire? Every February, when the stars align just right, Horsetail Fall in Yosemite National Park gets a sensational makeover. As the sun sets, its rays hit the waterfall at the perfect angle, transforming it into a blazing display of vibrant orange and red hues. We don't know exactly who and when discovered this natural miracle. The original valley dwellers may have known about it, but they kept it to themselves. It wasn't until 1973 that photographer Galen Rowell captured the first known photo of the waterfall, bringing it into the limelight. Since then, the firefall has become a global sensation, spreading like wildfire on social media and drawing crowds from far and wide. This magnificent cascade draws hundreds of spectators every year, but they can only see the show under certain conditions. First things first, Horsetail Fall needs a flowing stream. If there's not enough snowpack in February, the waterfall won't have enough water to create the magic. The temperatures must be warm enough to melt the snowpack during the day. If it's too chilly, the snow will stay frozen, and the fiery spectacle won't ignite. Second, we need a clear western sky at sunset. Those sunbeams need a straight path to hit Horsetail Fall and make it come alive. And since the weather in Yosemite is ever-changing, clouds can magically clear up just in time for the show. If all the conditions are just right, you'll witness the Yosemite firefall in all its glory for about 10 minutes. The mystery of the sailing stones in California's Death Valley National Park has puzzled scientists for years. Heavy stones seem to have a mind of their own and move across Racetrack Playa, a dried-up lakebed. They leave behind a trail on the cracked mud. There were all kinds of theories to explain this phenomenon, from magnetic fields or dust devils, which are strong whirlwinds, to mischievous pranksters. No one has actually witnessed these rocks in action, which only added to the mystery. In 2006, a NASA scientist named Ralph Lorenz entered the scene. He was studying weather conditions on other planets, but he couldn't resist the allure of Death Valley and those elusive sailing stones. He had an eureka moment while tinkering at his kitchen table with a Tupperware container. Lorenz filled the container with water, leaving a small rock poking out, and chucked it in the freezer. Then he placed this icy construction in a big tray of water with sand at the bottom and gently blew on it. The rock began to glide across the water, leaving a trail in the sand. Lorenz had been studying how ice can make big rocks float and move along tidal beaches in the Arctic Sea. Applying this knowledge, he and his research team figured out that, under certain winter conditions in Death Valley, enough water and ice could form to make the rocks float across Racetrack Playa in a light breeze. And as they glided, they left their mark in the muddy terrain. The River of Five Colors, Cano Cristales in Colombia, has the unofficial title of the most beautiful river in the world. For most of the year, it looks like any other regular river. The real magic happens between the wet and dry seasons, when the water level is just perfect. This unique river floor is lined with a special plant, and when the conditions are right, it bursts into a dazzling display of colors. Think vibrant reds, stunning yellows, and lush greens, all mingling with the blue water. It's like stepping into a living rainbow with 1,000 shades in between. This phenomenal display only lasts for a few weeks, from September through November. During Colombia's wet season, the river flows too fast and deep, covering up the river floor and denying the plant the sunlight it needs to turn red. And in the dry season, there's simply not enough water to support the vibrant life in the river. So you have to catch it at just the right time. The reason behind Maldivian beaches glowing in the dark at night isn't a mystery, but it doesn't make them any less impressive. It happens thanks to the bioluminescent plankton. These tiny creatures are like little underwater disco balls, emitting a cool blue glow when they are agitated or on the move. Imagine walking along the shoreline and leaving behind glowing footprints. You can even take a night swim amongst these magical plankton. Researchers have discovered that their bioluminescence is actually a clever defense mechanism against predators. When these microorganisms flash their little blue lights, it disorients and surprises their attackers. The plankton produces this light using a chemical called luciferin. These enchanting plankton can appear at any time of the year. The best chances of seeing them in all their glowing glory are from June to December. During this period, there's a higher volume of plankton in the seas of the Maldives, creating the perfect conditions for a luminous show after the sun sets and the night sky takes over. You'll only witness the magic of bioluminescent plankton when tidal currents bring them close to the shore in large numbers. It's hard to predict exactly when this spectacular show will happen, so make sure to do your research and prepare to take photos with a high ISO to capture it, exactly like it looks in travel catalogs.
Alert! Alert! Leave all your things behind and find safety immediately. The southern continent has just erupted. This is not a drill. You see people running around, screaming their heads out. Cars bumping into each other. The whole nation is in panic. You're on the southern coast of Australia, but the sky is black and it stretches further than your eye can see. Your friend in southern India calls you and says the same thing. There's ash in the sky and it's raining down on you. You hear rumbling in the distance, and it isn't even your stomach to blame. Everyone starts running inland. The black clouds swallow up everything in sight. Cars, trees, buildings. You're unable to see anything in front of you. Everyone's confused and scared. A tsunami breaches the shores, covering everything in its path. This is the Great Antarctic Eruption. Antarctica is that big continental desert covered in ice. In fact, it's technically the largest desert in the world. It's also covered with a whole lot of volcanoes, just chilling around. Scientists discovered that there are 138 volcanoes in Antarctica, 91 of which are hidden beneath the icy surface, and 47 on top. And there might even be more. But most of these volcanoes are dormant. And for a volcano to be dormant, it has to be fast asleep for the last 50,000 years. The last volcano eruption was Mount Erebus in the western part of the continent. It's the most active volcano in the south side of the world and is roughly 12,500 feet above sea level. That's as high as stacking the Burj Khalifa on top of itself 5 times. There's a whole bunch of these volcanoes stretched across the entire continent. In the most concentrated region, the volcanoes spread the distance equivalent to that between Canada and Mexico. And that's not even all of them. Scientists have warned that if any of these interior ice-contained volcanoes were to erupt, they'd melt the western Antarctic part of the land and increase the spill of ice into the ocean. It would raise the sea level and flood many endangered lands that are already at risk. And that's not mentioning the tectonic plates shifting underneath the surface, which allows some of the magma to squeeze its way to some surfaces. It's scary enough to expect what would happen if a huge volcano erupted. But what would happen if all the volcanoes in the Antarctic continent erupted at the same time? If you were one of those scientists on a boat on their way to conduct some experiments, you would begin to feel unease. You'd notice the water carrying a bit more of the current than usual. You look at your fellow scientists, and they too have the same look on their faces. As you land at the shore and take out all your tools and equipment, things don't seem normal. But the work has to be done. You head to the base and settle in. Business as usual. In the barren land, you see some emperor penguins waddling around, hunting, playing, and doing penguin stuff. But as you look around, you notice that the penguins all suddenly head to the ocean, and many of the wild Antarctic birds also begin flying towards the horizon. Weird. Then the ground starts shaking, and behind you appears a tower of smoke reaching to the sky. The ashes from a volcano can be very harmful for anyone with lung conditions, and even healthy people. The gases that come with it are usually blown away quickly, but are also harmful to humans and cause irritation to the eyes and throat. But if you're nearby, you may need a gas mask, or better yet, evacuate! The gases and ashes are the most dangerous part of a volcanic eruption. Even though the lava spewing and explosion may seem scary, the smoke in the sky can spread far away and even halt planes flying around. You look to your fellow scientists and they signal to you that it's time to go. Make like the penguins and swim off. But the waters are extremely rough and the rumblings getting louder and louder. Suddenly, you see more smoke wafting towards the sky, but from different locations. Back to the boat! It's sad to say, but leaving all that equipment was needed to survive. Carrying all that stuff would have slowed you down, but you're safe. For now. Looking behind you, you see a dark smoke screen covering every corner of the continent. Volcanoes have different types of eruptions. It's not just the shooting out lava into the sky scenario. They can range from aggressive to calm. Some spew out lava and some don't. This all depends on the environment, the number of gases contained, or if there's any groundwater present, and even the chemistry of the magma. So, chances are you'd be seeing all various types of explosions around you. You're out of Antarctica's mainland, but it's surrounded by lagoons and giant ice caps all around. You're doing your best to maneuver around them. But the ash is falling down all around. The sky is dark as the smoke blocks out the sun. Volcanic ash comes in all sizes and can cause different damage, from as little as lung and eye irritation to smothering vegetation and crops. And that's just the thing. More often than not,
These volcanic ashes are extremely thick. They can even collapse the roofing of some buildings if a lot of ash is accumulated, not to mention blocking roads and compromising aquatic life. And that flash in the sky isn't your imagination. Ash clouds in the sky are so powerful that they create electrical fields that can create lightning storms. And these bad boys can interfere with radio signals and even start fires. Also, these clouds are extremely hot on their own. As if that lava flow isn't enough to start any fires. Oh well. But there are some volcanoes that are explosive, and along with the ashes flying around, there are flying rocks. This overheated rubble comes striking down like meteoroids from the sky and can be pretty dangerous. You see the rocks hit the surrounding ice caps and water around you. As you reach a somewhat safe zone, you see the volcanoes all nicely lined up behind you, spewing all that thick red gooey fire. But the water tide isn't exactly peaceful. Volcanoes near oceans and seas can even cause tsunamis. Great. Submarine earthquakes shake the ocean bottom and produce large, powerful waves. And don't even think about surfing on them. If there are volcanoes spitting out red-hot lava, then why hasn't all the ice in Antarctica melted? The answer lies beneath the Earth's surface. Tectonic plates barely move underneath there. It's pretty safe to say they're stable. So for such a large piece of land, the coldest continent on Earth, the few active volcanoes are insufficient to melt all the ice. The real reason why the ice is melting and water levels are rising is the warm ocean current around Antarctica. But this time, they're all erupting at the same time. With the volcanoes discovered, who knows how many are left underground, covered in ice? And that's the scary part. Some of these volcanoes are hidden so deep beneath the icy surface that they now heat up from the lava spewing out. The ice begins to destabilize everything around. The ice on the ridges begins cracking open little by little. Like giant cans of soda bursting open, lava shoots from the snowy depths, causing enormous cracks in the ground. And then, magma finds its way to the party. This uninvited guest will begin to melt the surroundings, causing the ground to destabilize even more. Slowly but surely, the ice around Antarctica will melt. And if all the ice is melted, the Earth's sea level would rise by around 230 feet. That means coastal cities would be submerged underwater. The ocean currents would be flipped around, and hurricanes and typhoons would not want to take a break. Marine life would be in danger, and many small islands would completely disappear. And not to mention the smoke in the air that would travel around the world, halting many flights in the southern region. And if the winds were strong enough, the whole world. The economies would flop, and a worldwide panic would begin. Health emergencies all year round. Yeah,